Hello everyone. Today I am going to discuss the last problem of AtCoder beginner contest 353, which is Merchant Takahashi. So what is the problem? The kingdom of AtCoder has n towns from 1 to n. To move from town I to town J, you must pay a toll of C into absolute difference between I minus J en. Takahashi, a merchant, is considering participating in 0 or more upcoming markets. So what the problem statement says that you have n towns, right? From 1 to n you have n towns. From 1 to n you have n towns, and there are m markets. The each market is defined by which town it is at. So let's call that Ti. And what is the value, what he will earn, profit I, from that market. So each market is defined by two integers, Ti and Pi. Ti means in which market it is, and Pi means what is the profit you will get from this market. Now the markets are in ascending order, right? So at first one market one will happen, then after that market 2 will happen, then after that market 3 will happen. Okay. So like that, you first you can attend the first market, then you can attend or not attend the second market, then you can attend or not attend the third market, like that. Okay. So initially he is at town 1. Now let's say the town, the first tuple is let's say 2 comma 5. So let's say he wants to go to the first market. So the total cost he will, what he will earn is that he will earn profit of 1. So it will be P1 minus, it will be 2 minus 1 into C. So C will be given in the problem statement. I hope you get it. Okay. So he can attend any of the markets, any subset of the markets he can attend, and you have to return what is the maximum profit he can earn. Okay. Let's now let's look at one problem, one example. This example, 635. Let's copy this. Okay. Let me write it here. So this means the value of C is 3, and there are total 6 towns. So there are 1, 2, 3, 4, 5, 6 towns. The first market will happen at the fifth town. So the first market will happen in the fifth town, and the profit gain from the first market is 30. Similarly, the second market will happen at the second town, and the profit will be 10. Now what is the optimal way? So the optimal way is to move to the town 5. So move to the town 5 means that attend the first market. So after attending the first market, what is the profit? The profit is nothing but 30 minus, he is moving from the first market to fifth market. So the total cost of this will be 5 minus 1 into the value of C, which is 3. So it will be 18. Okay. Now after that, you are advised to go to the third market. So for the third market, the profit value is 25, and you are hopping from the fifth market to the fourth market. So the total cost will be 5 minus 4 into 3. So it will be 22. Okay. Now again go to the last market. So the cost will be 15 minus, you are going from 4th to 2. So it will be 4 minus 2 into 3. So it will be 2 into 3, 6 plus 9. So total cost will be 18 plus 22 plus 9, which is 49. This is the optimal way to visit the markets, optimal subset of markets you are visiting. So the total cost will be, optimal answer will be our 49. Okay, I hope you get it. Now the first observation we have already made is that the order of market does not matter, because we have to always go from the first market. In the increasing order of markets we have to go. So the order of market does not matter, only the subset of markets matter. Now let's discuss about observations. So what is the observation? Observation is obviously our brute force solution. Our brute force solution is the all visiting all the subsets. So for visiting all the subsets, the solution is using bit mask. So you can iterate over all the possible 2 to the power n number of masks, and check what is the cost. Okay, so the overall time complexity is order of 2 to the power n. So I am not going deep into the brute force solution. You just have to iterate over all the 2 to the power n number of subsets and try to calculate cost of each of them. So the overall time complexity is order of 2 to the power n into n. Okay, kind of. So this is definitely not possible, because the constants on n is around 2 into 10 to the power 5. So let's discuss about some more observations. So some more observations for discussing the more observations, we have to first find the formula. What is the formula when we are transitioning from one market to another market? So here you can think about one recursion state, that we are recursing on the ith market. Let's say we are iterating on the recursing on the ith market, and we are going to the jth market. So we are going from ith market to the jth market. Okay, and obviously I will be greater than j. Now, sorry, my bad, I will be less than j. Okay, so the how the value is changing, how the value of, let's call it dpi, because we are using dp, so let's call it dpi and let's call it dpj. Now let's look at what will be the formula for this dpi and dpj. Okay, so the value of dpi will be nothing but dpj, maximum value of dpj plus absolute value between tj minus ti. Okay, absolute value between tj minus ti into c plus our pi, right. So this is the formula for calculating the value of dpi. Okay, now look at that some term we can separate out, because only the terms that are related to only ti or dpi, only index I, we can separate them out. So dpi will be nothing but our ti into c. It could be possible that it is ti into c plus some function of j, or it could be possible this is minus ti into c, plus some function of j. The function of j also changes when we are changing this value. So let's call it f of j, and this is, let's call it f2 of j. Now when these functions, let's say we only have only one condition, that the first condition or the second condition. Now the problem becomes quite straightforward. We can traverse from the rear end of the markets. So we will traverse from the last to the first, and we will try to compute what is the value of dpj. Okay, what is the value of maximum of this function? We will try to compute maximum of this function, but here the values are changing. Okay, the on the basis of tj, the value of dpi is changing, so we can't really take one max, right? We can't really take some maximum of the function, because the function could differ when j is different. So this is not possible, so we have to think differently. So how we can solve this? So we have two values, right? I have already explained. We have dpi. There could be two possible values. First one is minus ti into c plus f of j, maximum of all the values of j, and it could be also ti into c plus f2 of j. Okay, then f and f2 values are different. Now if only one of them persists, then the answer is easy. We can take some suffix max and we'll get our answer. But here the fj values is can differ varying on j, so this is not possible. So how we can solve this? So instead of storing dpi, why don't we store it as dp of ti? Okay, so let's call it dp of ti. Now the dp of ti value will change. Okay, let's say let me draw the number line. Okay, let me draw the number line. Let's say the value of ti is here. Now for all the values, for all the tj's that lies in this range, and the value could be this one, minus ti into c plus f of j, and all the tj's that are lying in the right, the value will be ti into c plus f2 of j. Okay, so we'll have two arrays. One is dp1i and another one is dp2i. dp1i will store these values and dp2i will store these values. So now I will jump into the code and I will try to explain the code along with the approach. Okay, so let's jump into the code. So here we are trying to get some prefix max and suffix max. So and the values may change in the prefix and suffix. So we can't really store them in some prefix array or suffix array. We have to use some dynamic data structure like segment tree. Okay, So I for the finding the values, two segment trees we are maintaining. One is this one and the second one is this one. Okay, so we have two segment trees. One is seg and another one is seg2, and this segment tree are returning the maximum values. Okay, so this part of the code is quite straightforward. Maximum segment tree code. Uh, there is no nothing new here. You can look search what is maximum segment tree. You can find the code in the GFG or CP algorithms. Okay, so I'm not explaining this. No, so let's come into the original code part. Okay, so initially we are initializing everything with negative infinity. Okay, now what is the left value? Left value is our this one. We are trying to find a left value from this ti into c plus ti into c plus fj. Okay, so we are finding left value from this ti into c, and the right value we are getting from this minus ti into tj into c, tj into c into fj. Okay, we are getting the left and right values. And now what will be the our current value? Our current value is that we are not considering the next markets. We are only considering the current market, so the value will be pj, pi. Okay, we are not considering any other market, so our value will be pi. Now if we are considering the markets which are uh, considering markets in which towns are left side of us, then we have to add minus ti into c plus pi. Okay, because the markets are left side of us, then our value will be nothing but ti minus tj into c. We have to subtract this minus ti into tj into c. So when we are subtracting this, uh, we have to add minus ti into c, right? We have to add minus ti into c. That's why we are doing left minus ti into c plus pi. We have to add to both left and both right. And for the right case, this thing will get reversed. So in the right case, the value will be minus tj minus ti into c. That's why we have to add minus minus plus. We have to add plus ti into c plus pi. Now our value will be maximum of all these three values. The markets which are lying on the left side, markets which are lying on the right side, and only the current market. Okay, now our answer means that we are considering that we are jumping from the first town to this market directly and not taking any other markets in between first and this market. Okay, so we are jumping from the first town to this market. That means that this is our first market. Okay, that's why we are calculating answer equals to answer plus val minus ti minus 1 into c, because we are jumping from the first town to this market. Okay, and now we have to update in the left array we have to update val plus ti into c, and in the right segment tree we have to update val minus ti into c. Here you can see that in the left part we have to subtract, but when we are updating we have to add plus ti into c, because all the values which will be lying on the right side of it, we have to subtract those values. Okay, I hope you get it. If you are not getting in any part of the code, you can rewatch the part and try to think, take a pen and paper and consider cases that why we are updating that. Okay, you can just take this first example only and try to dry run this code. I hope you will understand. If you still have any doubt in any part of the code or explanation, you can always ask in the comment section. I will provide the link of the code in the description box also. If you find this video helpful, please like the video and subscribe to my channel. Thank you.